The name of the course, TPG. Can you see fine from there? TPG. Yes? All of you? Okay. Field development. Okay. Field development and operations. My name is Milan Stanko. I have been at the department now with my current position, 2 years, and I have been teaching this course for the last 3 years. Okay. And as I told you, I basically work, or I mainly work in production. Okay. And production has to do with everything that is near wellbore, transport along the well, and then all the transportation system, flow line, pipes, pumps, compressors that take the fluid to the processing facilities and a bit of the processing facilities. So we are in the downstream, in a way, of the reservoir. Okay. So about classes, we have it here, I think, both days, today on Thursday. So classes are on Tuesdays from 8:15 to 11, and on Thursdays from, I think it's from 14:15 to 16, right? So I propose, I'm not sure how many of you can, but I would like to move to make a change and to start here at 9:15 all the way to 11, okay? And then here have the flexibility to go all the way to 5, from 2 to 5. Is that possible for you? Is something that you want, or you prefer to wake up early and come here at 8? It depends on the group, okay? Some years people are a bit, not such a morning person. Like, I can see that you are a morning person, so maybe you don't have any problem with coming at 8. So maybe we take a vote to change or to keep it the way it is. To change? 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, versus to keep it the way it is. No, and we have some people that don't take any decisions. So what's happening? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, so it looks like it won. And those that didn't vote, now you're responsible. You carry the weight of your omissions. Okay, so we skip that, scratch that, and we keep it the way it is. I hope. The problem with A15 is that some people come a bit late. Okay, and then they have to wait. They have to start maybe 8:30, 8:45. But we'll try. Okay, and usually it's typical that we divide the lecture, or we have 1 day for exercises and 1 day for theory. Okay, my classes, I like to combine both elements in the same class. Why? Because if I give 3 hours theory, you tend to get bored. Okay, your mind starts to think, well, I have to pay this, I have to go there, there is a party here, I have to study this. Okay, if you spend too much time talking. So I like to put exercises and theory in the same session. I hope also that's okay with you. So mixed theory and exercise. Okay. Okay, my handwriting is not the best. Okay, so if you don't understand something, just let me know. What did you write there? Or maybe, okay. Also, exercises is referring to exercises that I make myself here with Excel or with the journal, that I show you how to do it step by step, and hopefully also you're following. Okay, so made by me. So it's important, and I encourage it if you want to follow it please bring your computer to class. Okay, bring your laptop if you have, or if not, team up with another friend that has a laptop. Okay, because I think it's important that you follow what I'm doing. I usually try to do it slow enough so we all go at the same pace. Okay. Otherwise, you have the recording, so you should be able to do it yourself at home. Okay. Okay, so that's something very important. Try to bring the laptop. Okay, or team up with a friend. Okay. to follow the exercises. And also there will be some other exercise sessions where you will be the main participants, okay? And I will just be going around and giving you advice if you need, okay? And you will see why we will make it like that. But some others will be done by you. Usually we have, that will come later, but around 5 or 6 home exercises that they account for the grade. You know, this course we have 60% is a written exam and 40% is exercises or project, okay? And we have here around 5 or 6. Okay, last year were 5. I think the year before was also 5. Okay, so you should expect something like that. But we will try this year to try to make some of these exercises in class. Okay, some people were saying that it's too much load. Okay, especially they had people that took other courses. They had a big load because they also had a lot of projects in the other courses. So we will try to have some of these in class, so you have more time available for consultation, to discuss things in group, okay, and you will hopefully move quicker. There is no problem to do it. People did it very successfully and they got very good grade, but it takes time, okay? It's not something that you can do with the left hand, and it takes time. 5 or 6 sets, okay, and each one of them has maybe 3 questions, okay, 3 okay, so we will try to do some of these exercises in class. Okay, hopefully if we have time. Okay, so one more thing about consultation. If you need consultation, I don't really have a formal time for consultation, but we can do it after class. Okay? Okay, after class, I give 1 or 1 hour and a half, and if you have questions, please just come to my office. My office. Wait. Okay. My office is in the, I think it's room 230. It's in the 2nd floor. You go on the reception to the right, and you continue all the way. The reference is the toilet, okay? It's a bad reference, but it's a good reference, okay? If you're lost, they say, no, go 3 offices, count 10 offices. No, you just say, I'm in front of the toilet, okay? Doesn't sound so good, but it's effective, okay? 230 is 1st floor, 2nd floor. Okay, my email .stanko@ntnu.no, and just try to write email when it's strictly necessary, which is something very important. Our focal point to manage the course and the questions is going to be its learning. Okay, and we will try to use, I usually try to use the forum option on its learning, that you can create a forum where you can post questions, okay, about the exercise, about class, about everything. And the important thing about that is that everybody can see your question, even if it's anonymous. And someone might have the same question that you have, And when I take time to answer it, and when the assistant takes time to answer it, it's also the objective is to give you an answer, but also to give to those of them that have the same question, that they will have an answer. Okay? So just if it's something is very personal and strictly necessary, okay, write me email. But the main tool, the main communication tool is It's Learning. Okay, so please, if you don't have access yet, who doesn't have access here to It's Learning? All of you have? Yeah? Okay. Because I've seen that there are like 2 guys that they haven't logged, so usually these are the ones that still don't have access. But so check it frequently. And use the forums. It's called, I think, discussion. Okay, and I will open a discussion tool soon that you can ask general questions about the course. But I like to give the answers there and also the assistance, because then you save time to answer the same question 3-4 times. Yes, let's see. So these are all the boring details. Okay, student assistants. We are lucky and we have 2 this semester, and their names are Radmila, and the last name I have to copy. Mansieva, is that how you pronounce it? No, she's from Kazakhstan, I think. Yeah. Nobody knows Russian or no? Okay. Well, then we will stay with my pronunciation, Mansieva. Okay, and let me see if I have a picture here. How she looks like. She cannot escape. Okay. And I will put the contact info. I don't have here the email. Okay, but she's one of the persons. She took the course with me last year. And then we have Vemund, Flattebacken. Okay, and I don't have a better picture. Maybe it's a very old picture, but you see, more or less, you recognize the guy. Okay. So they are going to be your main contact points. They have taken the course. They know the content, they know the exercise, they did pretty well. So just please also trust in them, and they should be the main contact point on the exercises. Okay. Another thing that is missing, it's okay, the written exam. We already have a date. And it's on the 15th of May, quite early, okay? 15th of May. Okay, at 9. And the duration is 4 hours. And we will give more details, but just keep it in mind and put an early marker on your calendar. About the exercises, so a requirement for the exercises is to deliver all but one to get access to the exam. Okay. Okay. That means if we give 5, you have to deliver at least 4. If you don't deliver 5, that's going to affect your grade, okay? Because they have the same, usually they have the same weight. But you will still be able to apply for the exam. But you have to at least deliver all but one, okay? and the compound grade has to be 20 out of 40. Okay, that means it's not just valid that you delivered an empty or you just delivered the headers. Okay, you have also to have some grade in these exercises. Okay, usually there is no problem, nobody has had any problem with that, but just to have the rules of the game clear. And there will be a penalty for late delivery. We usually have deadlines, and if yeah, someone doesn't deliver on time, there will be a penalty. Okay. Okay. So far, so good. Yeah. Any question? No. It says boring, but these are the rules of the game. Okay. So we are clear from the beginning, and there are no problems. Okay. Yeah. Then the recording of lectures that I usually take some time because I have to make the recording, then I have to convert it to another format, and then I'm going to upload them on It's Learning. Okay. Any of you has problems putting them on YouTube? Do you prefer YouTube than It's Learning? Okay. Yes? No? Okay. We'll see. But nobody has any problem with YouTube. Okay. All of us are, I say, social media guys. Let's see. Okay, the reference group, that's something that is very important. Okay, the reference group is to communicate the main persons, and usually have to be 3 due to a group of this size, or at least 2. And they have to communicate. You have to tell them all the rest. If you have any suggestion for the teaching, if you feel like there are too many exercises, if you feel that I'm going too fast in class, anything that can help, and especially constructive criticism, okay, that can help to make the class better. You communicate to these persons, and we have often meetings, maybe 3 or 4 times a semester, where they tell me the feedback, and then I try to take some actions. We agree on some actions. So can we have, please, at least 2 or 3 guys or girls from here that are willing to take this role? It doesn't take too much of your time, maybe just 3 meetings along the semester. So any volunteers, or if you're shy, you can send me but I prefer that you give me your name to have your commitment to the cause early. No? Nobody? Okay, so then if I will wait until next class, if not, I will just pick 3 names from the list. Okay? Yeah, so then the last thing on the rules of the game is the bibliography or the support material. And we really have, I really depend on a bunch of sources. Okay, there is one main source that you don't have to get it, but it's just if you want to have a textbook that we use most of the course. We use this textbook for support. Okay, Hydrocarbon Exploration and Production by Jan, Cook, and Graham. But what I usually do is I try to take some extracts from different texts, and I will put that together in a compendium, and I will upload it to It's Learning. Because really we won't be using all of the book, just some selected chapters. Okay, maybe 20% of this book, and then we will use some papers, we will use some other book, we will use some notes that I have written myself. Okay, so I will put all of that material together and under compendium, and you can use that printed and use it like your main text. Okay, but if some of you want to get a book or this is the closest that has more or less the full pensum. Okay, Okay. Any questions? No? Okay. Let's talk a bit about, just to show you what is the content of the course. So yeah. We are in this course, we have two main components: field development and operations. Okay. So in development, we have is two different ways to look at the problem, and they are two completely mindsets and two complete constraints and two completely different ways of what you have to make in each one of the phases. Okay. So when you are in the development phase, you have a lot of flexibility. You still things, you haven't decided completely all the features on your system, or even the system that you're going to use. So you have a lot of flexibility. But also the problem is that you have a lot of uncertainty. You don't know exactly, in many of occasions, you don't know exactly what you have in the subsurface, and you have a lot of uncertainties. So to cope with that, there are many ways to do it, and we're going to cover some methods in this course, okay? But usually you try to run sensitivity analysis. You reach to one conclusion if you use one value, but then what happens if you change the value within a range? Okay, what will happen? Your decision still holds. And then running different scenarios and analyzing which one of them is the best for your field, and also maybe running some optimization. Okay? You want to find, ideally, you want to find the best option, but there is just too much uncertainty that you cannot be sure. If you change some parameters, maybe the best that you found before is not the best. It's not the best, still the best. Okay? And then we have another part. So we are going to devote a big part of the course in the development, okay, field development process. And it changes very much from company to company, from person to person, from region of the world to region of the world. So what I'm going to give you is the main skeleton of the process, and then give you some specific tools that you use in each step. Because really, to follow like a cookbook, it's impossible. Okay, every company has a slightly different process. Okay, but the elements that you have inside usually are the same, the ingredients. Okay, so that's going to be our main task, and we are going to devote a big part of the course here. Okay, and we will see just now the topics. And then in operations, you have a completely different situation. Okay, in operations, you already are tied to a system, to a physical system. Okay, you already have a physical production system. Okay, and you have to cope with its deficiencies. Okay, it will have deficiencies because there are some uncertainties that there won't come up until you are in the production, until you start producing, and you realize, oh, this thing that we assumed is not exactly like that, but it's different, and we took the decision based on that. So now we have to cope with these deficiencies, but also, most important, we have to exploit its advantages. Okay. Then we are very much constrained. Okay. If you want to produce more, maybe you can produce more because you don't have enough processing capacity. If you want to drill more wells, maybe you don't have more place in the platform. Okay, so we are operating in a constrained environment. And the focus is to effectivization. Yeah. To make things more effective. Okay, to try to reduce downtime, to try to reduce um, uh, improve maintenance. And a big part of operations is spent in maintenance and in troubleshooting. Okay. You have a problem in one of the wells, it has certain behavior, for example, it starts producing transient flow, or it starts producing less. So you want to know really what's happening, and then you have to first detect the cause, and then you have to take measures to address and to solve it. Okay. So these are the two, and of course it's very wide. Okay, and we won't be able to cover all of it, but we will take some elements first. The main, at least here, the main skeleton of the process, and then we will try to see different topics within this very wide topic. And of course, also you in your education here, you have had some courses in some other fields that I don't have to repeat. Okay, I will focus mainly on the reservoir and production side. Okay, you have some other courses in, we will see just now, economics and reservoir, that you see more in detail these aspects. Okay, so let's so the pensum, and that the pensum changes a bit every year. So exercises, usually some of them are the same, some of them change. And I just try not to look, if you have a friend that took the course last year, or if you have someone that gave you the material, so please try not to look at them, just if it's strictly necessary. Okay, but the exercises will be somehow different. Okay, so first we will start, and I will try to start today, life cycle of a hydrocarbon field. Okay, and here is the level, what is expected of you, how I'm going to teach it, and what do I expect you to learn. Okay, so this is just appreciation level. That's something that maybe you can talk about. Okay, you said in the future you will say, oh, I heard that in my course, or I can say, oh, these are roughly the steps, but it's not really something that you can do engineering on, that you can do calculations. Okay, that you can do any valuable engineering task. You can just talk. You are like a politician. Okay, so this is a politician just talking to the public. Okay. And there will be no exercise on that. Then we have on the field development workflow, or the process. Okay, and we have two main engineering tasks that are usually done in that stage, within that stage. And one of them is the probabilistic reserve estimation and cost estimation and NPV calculations. Okay, and we are not going to go through the full depth of it, but we are just going to cover the basics. Okay, and this we are going to give it at the level of appreciation. You know how the process looks like. Then you have some configuration, you understand, and you can perform calculations. And then you have enough engineering knowledge to make design. Okay, to be able to do it yourself or evaluate what someone else is doing and understand it. Okay, and here there are some engineering skills. These are generic, this is the topic, and these are some generic engineering skills that we use we expect to cover in these topics. Okay, so we have Gantt chart, NPV, spider plot, decision trees, Monte Carlo simulation, and basic probability. Okay, and the main tool that we are going to use is Excel VBA. How many of you are familiar with Excel and VBA? Please raise the hand. 3. Okay. And how many of you can bring a laptop to class? All of you? Okay, more or less. Okay. No, so we will need a very brief introduction to Excel. Okay, Excel, we could use MATLAB, or we could use Python, maybe we could use C++, okay, we could use some, but Excel, the advantage that it has, if when you are going to go out in the labor market in your company, Excel is a tool that almost every company has. Okay, And it's very powerful because it has this programming module called Visual Basic for Applications, where you can automate many things that are just computer tasks, something that you don't want to repeat over and over and over again. Okay? And that is especially suitable for this part where I told you there is a lot of flexibility and the values can change. You don't want to have one fixed value, but you have a range. So you see what happens if now I change this number. You have to repeat exactly the same process, but now with a new number. If you have to do it by hand, it will take you forever. If you master this automation that you have or these programming tools that you have in Excel or in any other software, that will cut dramatically the time that you use to do your tasks. Okay, so that's why we use Excel, and it has worked okay with PC and Mac, okay, that we have had in the past. So I hope it's the same now. Okay, then we are going to talk about offshore and some onshore field architectures and layout of production systems. Maybe you're already familiar with that. How many of you are taking in parallel this course, Subsea Production Systems? TPG 4200? None of you? With Sigbjørn Sangesland? Okay. We have some overlapping topics, but then it becomes different. Production manifolds and talk about pigging facilities, and this is just configuration, okay? You're not only able to talk about it, but you're able to sketch, okay? If you see a very complicated diagram and you are able to extract and distill from it what is the most important and what you need to do your analysis, okay? These diagrams usually they have a lot of information because many people are using them. People to run chemical engineers, mechanical engineers, petroleum engineers, so you really have to be able to distill and take what is important for you because you don't care about many things. For example, the electrical system, the control system, maybe that's not important for you. What is important for you, for example, is just the flow path. And then you have to extract it for this very complicated diagram. Okay? And you have to understand for that a bit what is the architecture of a production system. Okay? So generic engineering skills, we have engineering diagrams and drawings. Okay? And also to use your head for analysis. Okay? We take a break. Yes? You want just to refresh, wake up, take a coffee or something? Yep. Okay, we see you in 15 minutes. Then another source, it's you have a website. Maybe let's copy the address here. I will put it on the reference. Where was it? Bibliography. Okay. And there is there is some information. Okay, if you go to, I have just a starting page, the courses that I teach, some research, but here on resources, you can find my YouTube channel, for example, and you can find the lectures from last year. If you go to playlist, if you go to playlist, here you have the course of last year. Okay, so usually every course is slightly different, but you can see, and they have a slightly different sequence. Okay, but you can see the topics are usually the same. Okay, and it has 27 videos. Okay. Also, you have, let's go back, the YouTube channel. How many of you are taking this course, Reservoir Fluids and Flow by Curtis Whitson? Yeah, a big part of you? Okay. And I guess some of you already took it, right, last year. Okay. So these are some topics that, okay, so one more question. How many of you come from the International Master of Petroleum, in Petroleum Engineering? How many of you come from the 5-year program? Are there any of you that come from, how is it called, Subsea from Bergen, from the Subsea program in Bergen? No? Any of you coming from another department that is not petroleum? from, for example, natural gas, master, no? So all of you have more or less a good background in petroleum. That's what I'm asking, actually. Yeah, you have taken your basic reservoir course, petrophysics, production, reservoir. Yeah, more or less. Okay. Okay, so here are the notes. I'm going to put the link here, or probably I will just upload it to its learning. And here you have some material from past courses. So here you have the videos that in YouTube you cannot download, but here they are on a website that you can download. Okay, these are, for example, for 2016. You have also the notes, that is the PDF. What I do at the end with these notes that I write on the screen, I make them into a PDF and I upload them to its learning. Okay. So here you have the notes by date, and then you have the compound of all notes. Okay, so if some of you wants to go through it and wants to see the content, yeah, wants to check something in advance, you can do it. Then something maybe some of you are interested, the feedback from last year's. Okay, what people said was good, what people said was not so good. They are here. Yeah, and that's all that is relevant for you. Okay. Yes. Okay, so then going back, we are going to take this course is focused. Okay, so the main topic where we are going to have this course on offshore, okay, Norway, okay, or offshore, not Norway, but in offshore in general, okay, offshore production. And we will use some examples from the Norwegian continental shelf. Okay, we will cover a bit of onshore, but mostly, especially the development process, is going to be oriented to offshore. Okay. Okay, so that's why we have this section, dynamics of marine structures. That the offshore part is very important and plays a big role in the definition of the development concept. Okay, so we are going to have 1 or 2 sessions on that, and more specifically talking about wave statistics. How do you handle waves, and how do you use that information to decide which structure you are going to use? Okay, and here again, configuration and some engineering skills that you can actually do calculation. And if you see the generic skills, you have analysis. That's something that a good engineer always needs, but also you have modeling. A big part of the course has, if you see through the skills, they have modeling. Okay, modeling, it's important because maybe not all models give you exactly the same result as what you measure. Okay, but the thing about models is that they are based on the physical principles, working principles. Okay, if it's fluid flow, if it's temperature, if it's stress, resistance of materials, they are based on physical principles. Okay, and they help you. The real power of models is that they help you to understand your system. Okay, you put your equations there, you solve your equations, you see that's how I think it should behave, and then you see the result. And even though it's not exactly the same, they are after methods to try that the model will give you the same as the reality. Okay, there are some methods that you can adjust. Maybe you assume this parameter was this value, but this should be lower, etc. But the important thing that you should take from models is the understanding of your physical system. Okay, and that you can do sensitivity. You see what happens if I increase here, reduce here. Okay, that's the real power of models. So that's why it's an important element here, and I'm not pretending that you yourself become experts in making models. That will be my ideal, okay? But that you are able to use models in an intelligent way, challenge the assumptions that you took that are built under the model, okay? And in your career, most of you are going to use just software, okay? Simulation software. But you have to learn, or I hope that you get from this course that, okay, it's going to give you a number, but you have to be sure how to quality control this number, okay? And what are the underlying assumptions that this software or this simulator used, okay? Not just accept blindly the the and that's a challenge, and it's going to become with time even more and more a challenge. We're going to depend more and more on simulators, on computer tools, so etc. So you have to really to it's going to be a challenge for you, a challenge for me, a challenge for us in the future. Okay. Then fast Fourier transform for signal analysis, and we will be using mainly XLBBA. Then comes the part on the behavior of the reservoir that we will try to quantify how much the production performance of the reservoir and the production system. Okay? So we have a production potential, production scheduling, flow equilibrium in production systems. That this is going to be very helpful, especially for those that are working in production in the future. Choking, design of choking and boosting, and flow performance of surface and downhole production networks. Okay? Usually all the systems that have subsea wells or also many onshore systems, they have a network that commingles the production from the wells all the way to the facilities. And it's important that you're no longer dealing with one isolated well that you can study independently, but you have to check the interactions of these wells in the system. Okay, and this is taught in a design level, and again programming, problem solving. Okay, and we will use XLBBA, and here we have some tools that I hope we have time. Last year we had time to have 2 sessions on them. These are commercial tools, and we are lucky that we have the academic license that are used to. So first we start with Excel, so you see what is behind, and with a very simple case, how does it work? And then we go and use the commercial tool and see what is the equivalent, what we have done in Excel and what is the equivalent in the software. Okay, and of course the software has many more options, so you can get lost very quickly with all the options that it has. Any of you knows how to use any of these tools from before? Gap, Prosper, Pipesim? Have heard of them before? Yes? One? Okay. How many of you are specializing in production? 2, 3, 4, 5. Okay. Well, you know, you are the future of our branch, so. Okay, so then we talk about something very important that is flow assurance, and has to be taken into account in the design phase and also in the operational phase, which is flow assurance. And there is another course that is called multi-phase flow that discusses more in detail the fundamentals of flow assurance, but here we're going to orient how it goes inserted in the field development process and how you have to take care of it in the operations. Okay, and we are going to take 2 very particular examples. We are not able to cover all of them, okay, because flow assurance really has a very wide variety of issues. We're going to talk about gas and condensate transport in pipeline and hydrate formation, and for here we're going to take the example of the Snow White transportation pipeline, one of the longest in the world. Okay, and we're going to focus on the hydrate problem, and then we're going to talk about oil and water emulsions, what kind of challenges you have when you have transportation of oil and water. And for here we're going to take an example from an onshore field in Colombia that is producing heavy oil. Okay, and appreciation, that's the general flow assurance part, and then design on these 2 particular cases, and again modeling, programming, analysis, and problem solving. Okay, we're going to use, here appears another tool. Okay, HYSYS. How many of you have used HYSYS before? No? Okay, it's a tool that is similar to GAP, but it is mainly focused to model processing plants. Okay, components or equipment that you have in processing plants. Okay, separators, compressors, distillation towers, etc. Okay, and it's more focused on the thermal or pressure, volume, temperature behavior of the fluids. Okay, to make an accurate representation of the behavior, what happens with pressure and temperature, what happens with all the properties of the fluid. Okay, and when it changes in the equipment. So this we use more extensively than GAP and Prosper. Okay, and those of you taking natural gas, you're also going to focus very much on HYSYS. Yes, then we're going to talk about electric submersible pumps. That's a particular artificial lift method. Fundamentals, design and plan, especially how do we plan for field life, how we do select, or this is the early selection of ESP, planning of ESP, how do we introduce them in the field development scheme. Then also boosting design, subsea boosting design. We can use more of the same principles that for ESPs. We can use them for subsea boosting, and that's something that is going to become more and more common, and it's important to know how to tackle it. Then we're going to have a very short session on data management and allocation, especially how the data, what is this data structure and data infrastructure that you have inside the oil company. And then a particular use of this data is allocation. Okay, so we're going to have a short example on allocation. Then production optimization. Again, very simple cases. What is production optimization about? And some very simple cases. And integrated asset modeling, also abbreviated as IAM. Just the principles. Okay. And if you see in almost all of them, of course, we don't have an individual set of exercise, because then we will have too many. Okay, but we are grouping topics into exercise, and we have, for almost all of them, we have a set of exercise. And that's because I believe that you learn by doing. You learn, okay, listening to me here, maybe you get distracted, maybe, but you learn is especially by doing exercises. I can tell you, show you how to do it here, but the only way it's going to stick in your head is if you do it yourself. Okay, so exercises are important. So please try not to copy, and to do it yourself, and to... Okay, additional skills gained by home and class exercises. Group work. Some of the exercises are going to be in groups. Last year I think we had individual, groups of 2 and groups of 3. So I will let for each set what is the arrangement. So to develop one thing that is not officially in the course, but something that is important for me at least, is that you develop written and oral engineering communication skills. Some of you complain, like, or last year or the previous years, why do we have to write a report? Report takes too long time. Okay, why do we have to write text, and why do we have to explain our results? Okay, that's really the... I agree with you. The interesting part, or the exciting part, is to do the calculations. Okay, but then those calculations, usually to be completely useful, you have to present them to others in a way that they can really rapidly digest what you have done. Okay, and that's where it's important, these oral and written communication skills. Because I agree with you, the fun thing is to go sit, you do the calculations, or you go to the field, do the measurements, etc. And then you go and talk, oh, I found the problem. But that's not enough. You have to communicate so they can take actions, and you really can show the value of what you have done. Okay, and they can really be implemented, or they can really be taken into account. Okay, so usually in these sets we have the solving part, and then you have to make a summary, your analysis, you have to have conclusions, and that's hopefully going to prepare you for your career in the industry in the future. Okay, so just please, we will try to reduce that to a minimum, but it's important to communicate your results, to put it compact and in a very effective way. Yes, any question? No? Okay, any question about the topics? Some of you has is there something here that I could skip, that you already know from before, or you have covered from before? No? You didn't cover reserve estimation in the reservoir course? No? Any of these tools, have you seen it before? Monte Carlo simulation, decision tree? No? Okay. But they are usually also in this course, we have some people from the industry. They have been some years in the industry, and they can really help me to first to support the explanation that I give here, and also then that I can make my explanations a bit shorter. Okay, but maybe it's not the case this year. Okay, another comment. Too many things, huh? Another comment is okay, we are going to some fundamentals that we depend on in this course. Okay, is on material balance. Okay, I try. These are fundamentals that they should be pre-learned. You should already have these elements. Okay, but if you don't have, just in case, I try to make a very short explanation that is enough for you to continue and you to cover the topics that I have for this course. Okay, but just if you want to be aware of that, just we are going to use material balance. Okay, and that if you want more information, it's in this course by Curtis Whitson, reservoir fluids and flow, and he also has a YouTube channel with a lot of interesting videos. Then reservoir simulation is not so important, but also it's an advantage if you have it, and it's taught in this course. I think this is by Kleppe, Jon Kleppe. Then well inflow, that's covered in the course of Harald Aschheim. Okay. Fluid phase behavior, again Whitson. Then Blackwell model, also Whitson. Then single and multi-phase fluid drop-in pipes, computation of pressure and temperature losses. This is taught in, this is the course of Harald, and the course of process setting by Roar Larsen. How many of you are taking that course this semester? Nobody? Okay. Processing fundamentals, separation, again process setting by Roar Larsen. So let's put here the name. This is Whitson. This is Kleppe. This is Aschheim. This is Whitson. Yeah, the rest Whitson. Then you have Larsen. And yeah, and this is also Larsen. Okay, so if you, some of you, because some of you ask what can we cover, or I would like to read something before the course, or I would like to prepare a bit better. So if you are looking for something where to prepare, I will say just look into these topics, because we are going to be using these tools. As I told you, it's not strictly necessary, because I will try to give, if not many of you are familiar, I will try to give a short introduction and then jump into my topic. But if you want to, you feel like you need to invest some time to prepare for the course, I will just say, okay, just check these topics. And some complementary courses that I think are, some elements in these courses are relevant for our course is Introduction to Subsea Boosting. This is the course that I told you about by Sangesland. Again, this is Sangesland. This is taught by a professor called Bratwold. And this is an introductory course that is taught by different professors, but the main responsible is Stovas. Okay. And there are some things that are complementary that we are going to touch a bit, and that if you want more information, you can go to these courses, at least like a guest, and listen to them. Okay? Yes. Okay, so now we start a bit with the topic for today, a bit late, but we still have time. Okay, so where are we? Well, we are in P11, no? But what is this course? Where is this course located? Okay, so we are in the exploration and production branch of the business, of the oil business. Okay, you have exploration, and then you have production, and then you have transportation if necessary, then you have processing, okay, then you have refining, and then you have marketing. Okay, making products or delivering the product to the final consumer. Okay, we are located in this part, in the part that is called exploration and production, E&P. Well, this course, right? Okay. And it entrains to first try to discover where you have accumulations, methods to try to discover where you have accumulations of hydrocarbon, okay, then ways to exploit these accumulations of hydrocarbon and take them from the subsurface, processing them, and then having them ready to further processing, further transportation, to refining, and to get them into the market. At the end, they will go into like benzene in the car. They will be in plastic products. Okay, they will be just producing energy for us to use in our homes. Okay, electricity. But we are talking about that part, and really the boundary is that we have some processing, but we don't process until the final product. The E&P doesn't make gasoline or doesn't make plastic products. We just process to a minimum that you're able to transport it further. Okay, that you know the oil is not going to liberate gas anymore. Okay, or that the gas is dry enough so you can transport it safely to the powerhouse, for example. Okay, to downstream. And there are three main tasks that we have to make in this stage. Okay, and here there are two important things. One of them is the reservoir, okay, the accumulation. Okay, so it's the first thing is understanding the subsurface, okay, because that's really the most important element. There are many other things, and you will see in development, there are many other things that are around it. But really the central figure, the main actor in this play is just the reservoir. Okay? So we really have to get as much as possible to understand it. And that's a challenge because actually we can never go and sit there and exactly observe it, or we cannot be exactly sure of what we have. So it's a challenge, but it's one of the most important parts. Okay, then optimization of the development. Okay. And that refers in the first stage to try to find, like I told you before, the best alternative to produce this system that I have, to produce this reservoir that will give me the highest value. Okay, that will give me the biggest advantage. And then with time, when you are producing, is trying to keep things optimal, is trying to keep things as best as they can be. I want to be producing as much as possible from this formation. Okay, so you try to do, so this is in the development phase, and this is in the operations phase. Okay, and then the last part, which is very also relevant, is we have a destination. There is something where we want to send these accumulations to. Okay, the market. We should never, and you will see why maybe next class, why the market is so important, the destination. So commercialize, and we call it commercialize the resource. Okay. We have to be sure if what we plan, for example, is to put the oil in a tanker and sell it. We plan to, the gas is particularly important. What do we plan to do with the gas? Is there a pipeline transportation system where we can send it through? Okay, so all the time think about how we are going to commercialize the resource, and in that respect also the price of that resource is going to be important. What happens if the price goes up, if the price goes down? Will I still have a solid exploration and production case? Okay, so that's where we are. Okay, that's the particular place of the course. Okay, and then we are in time. Okay, what are we covering? This is the, let's call it the place, location, and then we talk about when. Okay, and for that we have to paint very simplified the life cycle of an oil and gas. Okay. So if you help me, what are the stages? We have something called pre-exploration, and we will see very soon what does it mean. Then we have the exploration, and then at some point in the exploration we have a discovery. Okay. And then we have appraisal. We want to know more information about this discovery. We want to know if it will have economic quantities, what are the characteristics, is it easy to exploit, what kind of problems we should expect by developing this asset. And then at this point we have to take our first decision to say, do we develop it or not? Do we go for it or not? Okay, so here is the first decision of commerciality. Then after that we have project planning. Okay, where we design the system first very roughly, and then we go and from bottom up we go from the easiest or the most simple general things, and we go expanding into each compartment, into each part, and we try to give more and more details, more and more engineering, such that is you're able to build it, okay, and you're able to put it together, all the components that you need for each particular functionality. Then you have the execution. That the execution is when you are building, commissioning material, installing equipment in place, determining all the final details of construction, contracts, payment, etc. Then you have, after that you exit the like the planning or the all of these we can call it like the pre-operation phase. Okay, so far up to here we are just spending money. Okay, up to this point we just have, if you see, really there is not much that can give us value here. We are not producing anything up to this point. Pre-operation, pre-production. So we are spending money until we reach this final step in the execution, where is that someone gives the key and say, okay, now you can run and start up the facilities. This is how you operate the equipment. And here we have operations, and after that we have one part that is not traditionally covered, but I just want to raise your attention. That is decommissioning, abandonment, and decommissioning. Okay, that is after you reach some economic level. You say, already the production levels from this field are low enough, are not giving me enough revenue, so I have just to stop production and I have to close the field. Okay, and this is simpler, it sounds simpler than what it is. You have really to plug the wells, you have to remove the facilities, you have to do many tasks, and this becomes huge a source of expenditure and time consuming, an engineering task. Okay, and many of the assets that we have now in the North Sea, for example, they are getting of age, and you get the need to abandon them and decommission them. So there is going to be in the next years a need for engineers to be involved in this particular phase of the field. Okay, so for you might sound like the most boring. We like to work here, and traditionally, yes, we like to work here. But now you have to think also, first, when you design your system, when you are in the project planning and execution, you have to think a bit ahead. You say, how I'm going to make the abandonment and decommissioning. Okay, and here we have some very important challenges and opportunities that are going to be open in the next years. Okay. Now, time frame. What do you think? How long is this? How long does this process takes? Okay, from here to here might be, for example, 30 years. Okay. From here, maybe to project planning and execution, something like 3 to 5 years. So it's not really up to scale. Okay. And then you have a long time, maybe 10, 15, 20 years, 25 years in operations. Okay. That's more or less roughly the time scale. Any questions so far? No. Remember, appreciation, so you have to, your effort is to try to keep awake. Okay? But we are teaching appreciation. Okay, now the person that executes the project, in this case the oil company, they have more or less the same process, okay, because they have more or less the same stages. They are very well defined, and you have very important milestones in each one of these processes. But this looks slightly different. So let me show you. That's how the project process of field development looks like from inside the company. Very similar, but slightly different. Okay, pre-exploration, exploration and appraisal, and until you reach the statement of commerciality, that's identification of business case. You want to know if you have something that is worth pursuing, to make a pre-planning, to try to find solutions, a concept to develop that resource. But all of that is called identification of business case. Here you have the discovery. Okay. Then you have, along the process, that's something that is especially applicable for companies in the Norwegian continental shelf. Okay. For example, Statoil. And this is actually, if you go and search on the internet, PDO NPD. Okay, these guidelines for plan for development and operations. Okay, you will see that it's almost given like a guideline that every company is going to have a similar project process. Okay, and DG stands for decision gate. So it's divided into stages, and the idea is that at the end of each stage you have some mandatory or required set of tasks that you have to have completed, and then at that point you have the power to say, okay, based on this information, based on the results, do we continue? Do we do some more work? Do we stop it? Or do we stop it? Okay, at each one of these decision gates. And they are like just quality control points where you have to make important decisions, but also that helps you to follow up your project in a consistent way. Okay, so this is based on that, and its scheme might look slightly different in each company, but to subdivide in stages, you have to do certain tasks in each stage, and at the end you have a decision gate, DG. Stands for decision gate. Decision. Okay. So let's first cover this first phase, okay, identification of business case. What does it entail? Okay. Okay, and the main goal of this stage is to demonstrate economic potential of the discovery and quantify and reduce the uncertainty about the recoverable reserves. Okay. Which makes sense. Okay, that's if you have a business case or not. If I have, for example, am I sure that these are the volumes within certain range of uncertainty? Okay, and to be able to quantify, or I'm sure that I have this value plus minus 20% or plus minus 50%. Okay, to be able to quantify not only the value but also the associated uncertainty, and we are going to see. So that's the main task. Okay, and some pre-task or pre-steps that it has are pre-exploration, activities, and scouting. This means to look at where do we have the potential to find reserves or accumulation of hydrocarbon. Okay, and these are mainly you use technical, because people that know, for example, that know the area, that you think that you have potential to find resources in the area. Then there are other considerations to take into account, for example, political, that you want to know that where you're in the place where you're going and you want to develop, there is a stable regime, okay, a stable government regime. So for example, you have geographical, all the challenges you're going to have, for example, deep water, Gulf of Mexico. So let's list some of them here. Pre-exploration activities, the main task is to collect information where there might be potential for hydrocarbon accumulation. Okay, and here you have many aspects to take into account that are, for example, so let's call this one the technical part. Okay, if the geology, the structure of the subsurface, the presence of a source rock, so that's the technical part, that you have conditions that are suitable to having accumulations. And also it's also important to see if you have had accumulations or discoveries in that area in the past. Okay, that's the technical part, but also taking into account many other things like the political aspect. Okay, how stable is the region, how stable is the area. Okay, the geological goes here together with technical. Geographical, okay. The social part, for example, if you are in a country that has a different scheme, it's the oil industry is what is the risk, for example, that the oil industry will be nationalized. Also environmental, if it's an environmental sensitive area. Okay, so this will tell you, the technical part will tell you a chance of finding reserves, and how big. Okay, and then the other aspects, for example, technical challenges in the area, if it's deep sea, if the taxation regime of that country is particularly advantageous or not, the personal security, if you're going to be having personnel from the company working in that area, if it's going to be safe for them, if there is environmental sensitivity. Okay, so that's the pre-scouting, and every company has a slightly different process. But then the second is getting, sometimes this is optional, getting pre-exploration access. And this is something that sometimes is called the exploration license. And is a non-exclusive right to an area to perform some kind of pre-exploration activities. And in the Norwegian continental shelf, this is usually, you're limited. You can run only seismic. That's in the NCS, Norwegian continental shelf. You're limited to run, if you get this license, it's non-exclusive. So you might have some other companies running surveys at the same time, and you can run only seismic, and you can run only shallow wells. Okay, in very seldom cases. But usually this step is just skipped because there are some other companies, scouting companies, that they do that for you, and they sell you the data. They have these pre-exploration licenses, perform some seismic, and they give you the data, and then the company can evaluate if it's worth going to that area or not. So sometimes this is done by specialized companies. Okay, not by oil companies, but by companies that they specialize in that, in exploration scouting. Do we take a break? Yeah, 15 minutes. Yeah. Okay. Yes. So after that, the final kind of step of that line is to identify a prospect. Okay, you try to identify an area that you think that there is a big and huge potential for a discovery. Okay, and after you identify a prospect, then you have to apply. There comes the process of applying for a exclusive production license. Okay, and the production license gives you the right to explore, develop, and produce. Okay, and I think the maximum duration in the Norwegian continental shelf is 10 years, and then it can be renewed. Please check, I think, but it's 10 years. And this is not an easy process. You have to really to show that you have expertise in the area, that you have the technical documentation why you want to explore and produce that particular region. Okay, and you have to be qualified. So this might be, for a new company, might be a relatively extensive process. And in the Norwegian continental shelf, there are two modes. One of them is called licensing rounds. These are in frontier areas where there hasn't been much exploration and that there is limited information available. Okay, so they call it licensing rounds. And you have APA, which stands for Awards in Predefined Areas. okay, which are more mature areas that probably have neighboring fields or neighboring discoveries, and there is a slightly better chance or known chance that you might find hydrocarbons or not. And just to show you, this is from the website of the Norwegian Petroleum Directorate has a lot of information. So if you want to know more details, you're planning yourself to build a company in the future and do exploration, or so they have all the information that you need. Okay, and this is just to show you the map. This was the latest, the 24th round of licensing in the Norwegian continental shelf, and these are the blocks that were available, and you apply for a particular block. Okay, so let's take a picture of that. Okay. And the cost, at least in the Norwegian continental shelf, it's for the first year is 34,000 NOK per square kilometer. Then the second year it increases to 68. And on the third year and further, it's 137,000 NOK per square kilometer. Okay. So if you are making profit, no problem, you can pay this cost. But if not, it's just costing on top of all the exploration cost, is just costing you money. Okay. And there are a way also is described in the website that you can waive. You don't have to pay that if you decide to develop, for example. There are some particular conditions that they waive these fees, because of course they are interested to get discoveries and to get production and to get more oil flowing to the market. Okay, and after that, after you get, which is just a line here, but it's a big process, take it into account. It's like applying for, I'm not sure, for a PhD, but maybe 1,000 times more the amount of documentation, work that you have to provide, and certification that you have to provide, etc. Okay, or applying for a job, or etc. Then you go to the phase of exploration. Okay, and exploration usually starts with performing some kind, if there is available, perform some kind of geological studies. Okay. Maybe some visits to site, if okay. Then geophysical surveys. Then seismic. Okay. Then comes the last part, or what we use first is all of these tools, and then we start with exploration drilling. After we have some idea by the seismic and all the surveys and the geological studies, what is the structure of the subsurface, where are most likely to be traps and source rocks and the reservoir rock. Okay. So here the most kind of relevant information that we gather in exploration drilling is quite a lot, and it's well cores. Then we have wall cores. Then we have the cuttings, that they give you something they allow to verify if you are in the formation or in the structure that you're supposed to be. Fluid samples. What kind of fluid do you have? What API does the oil have? How much gas does it have? If you have any water. Then you have a productivity test. Okay. These two are usually taken with something called DST, drill stem test. Okay, that maybe you can Google. I think there is a nice animation. I can put the link later. That you basically isolate part of the formation and you try to produce it in a controlled manner. And then when you produce it, you get fluids, and you can put all of those fluids in a bottle. And also you can check for that particular pressure that you impose how much fluids you're getting into the wellbore. And with that, it gives you an indication of the productivity of the formation, of permeability, of etc. Then you have also, of course, we forgot something very important, the logging. And if we are lucky, after all of that exploration, then we get a discovery. Okay, which is a very big event. If we go back to the main plot, it's a very big event that we have in exploration. Okay, we explore, and then we find some accumulation of oil or gas, Okay. Then after we have the discovery, after we have that particular event, then we have to start to evaluate or assess the discovery. Okay. And here is to determine the uncertainty and also to manage risk. Okay. Already we have spent some money doing exploration, so we want to be sure if we need some more drilling, if we need some more exploration, and we want to know, to be very sure of what we have, how much oil, how is the extent, what is the size, and what is the structure. Okay, so for that, some of the steps that are done here is probabilistic. With the minimum information that we have, we perform a probabilistic reserve estimation that we are going to cover this topic probably next week. Okay. And you have to identify and assess additional prospects. Okay, you want to quantify how much you have, what is the uncertainty associated, and if possible to reduce it. If it's big, we want to reduce it to a number that I can take, to a range of numbers that I feel comfortable making a decision. Okay. Okay, then we have an economical evaluation, a simplified economical evaluation, and that's just in terms of just the volumes. Okay, how much oil I have, how much gas I have, and for how much I will be able to sell it. So that gives you an idea, a number that puts a tag price on that hydrocarbon accumulation. Very simplified, not the methods that we will see later, like NPV calculation. Okay. Then you might decide if to perform field appraisal to get more information and to reduce the uncertainty. And here is a very, there is also a chapter that you can read, and it's also in the compendium, that is a bit critical to determine if to spend money to get information. If the money that you are going to spend, you're going to get it back with the information that you receive. Okay, if it's worth the investment for the return that you're going to get. And there are different methods to do that. But field appraisal to reduce uncertainty. Okay, it can be more exploration wells. And seismic, additional seismic. And here some factors that we want to clarify usually are fault communication. Okay. We want to determine the extent of the reservoir. The behavior of the aquifer. If it's an aquifer that is very big or is very small, or it will be able to support pressure in the life of the field or not. Also, some very typical things that we want to find out is where the location of the water oil contact and the gas oil contact. Okay. And etc. Some other things. Okay. And after that, there comes the last step on that. If you see now, we are in the process of making a business case, okay, identifying a business case, and we are up to here. Those are all the activities that are just in this part, just in this phase, okay. And we reach a decision gate inside the company. That's how they are handling the project. And then this decision gate has 3-4 possible outcomes. Then we reach decision gate. Okay, so we're going to cover, just to give you an idea, we're going to cover this part with Monte Carlo simulation, a very simple case, simple example, but just you see more or less what are the tools that they use, probably next week. And this part on field appraisal, that is using decision trees, is using some other methods to deal with uncertainty. Probably we're going to cover that in not next week, but the week above. Okay. Then in the decision gate, we have several options. You say issue a SOC, statement of commerciality. Okay, that you say, actually, I think they are economical reserves, I think they are economical accumulations, and we are going to go forward with trying to propose a design how to exploit these reserves. And there are some numbers, I think, in the book, in this something that I'm going to tell you to read for next class. They talk about 100 million barrels at least for an oil reservoir, of course depending on the conditions, but that's kind of a rough rule of thumb number. Okay, issue a statement of commerciality, or they call it also ROC, I think is called report of commerciality. Okay, and continue. Then you proceed to next phase. Okay. Another option is that you say, do more appraisal. There are some critical things we haven't been able, with what we have done so far, to reduce the uncertainty. And there are some things that we just really can't take a chance. They have just too much chance of being one value low or one value high, that we have to be sure, or we have to reduce that uncertainty. So we decide to do more appraisal, to wait for the decision and repeat a bit of the last phase. Okay. Then another solution might be sell the discovery. And there are some companies that they do a discovery, but they actually not planning to develop. With the discovery and all the findings, all the evaluations, they go and sell it to a bigger company that maybe they're willing to develop it further. Okay, that's also very typical in the US. Then you have do nothing. You still have the production license, you still are the owner, and you maybe wait a few years. For example, this is if maybe it's very remote, okay, and the reserves are very small. But if you had someone around you that you can send your production to, then that will become economical. So you're going to wait a few years if, for example, some neighboring block or neighboring company are going to find some resources and try to do an area development. For example, do nothing, wait. But of course, the government doesn't like that very much. You're sitting just idle, just not producing. Okay. Or relinquish the saddest outcome, relinquish to the government. And also, if it's something that is non-economical according to you, to the company, so they say, okay, we give back the production license. Okay, now you can offer it again, you can give it to another company, whatever you want. Okay, so that's in decision gate 0. Some questions so far? Are you still awake? Yeah? No, not so much. Okay, just this first part it's not too many exercises, just text and talking. So okay, then comes the part after that is approved, after I pass that decision gate, then comes the part, all of this that is called project planning. And the planning is done, of course, in several stages. One of them going from the most general, then becoming an increasing in complexity. And from the where you have least defined things and where you're defining every very small aspect. Okay? Usually we have many options and then we close. Oh, I think the best are these, and then I close. Then inside of these options I have maybe just this, and then I go narrow and narrow and narrow until I reach a development solution. Okay? And they are divided in, that's just names. Again, we can have different variations for the different companies, but feasibility studies, where we study, the idea is that it's more general. You have just one main concept, rough concept. Then you go on the concept planning, you propose many and more detailed concepts. Okay? And then the pre-engineering is where you already have selected a concept and you want to refine further all the details of that particular concept, development concept. So let's go and just give some tasks that are within this, but remember all of that enters into the project planning phase. Okay, I'm just planning the okay, so let's go project planning. By the way, how is it going with the handwriting? So far, so good? Yeah? Okay. Okay, then we have feasibility studies. Okay, then is to find one or more concepts, and this is very general. Okay, that are technically we have a mistake, technically, commercially, and organizationally viable, okay, to develop the resources that we have. Okay, that's the main, to find, just to map, to do sort of a screening and to say we have this variety of concepts, and this usually comes from the experience of the company and things done in the region. Okay, we know that we could use, for example, this for example, if it's offshore, we're going to use a floater, and then we're going to re-inject the gas, for example, and send the oil with a tanker. Or I'm going to connect to this gas pipeline, and then I'm going to transport the gas. But it's very rough. It's very rough concepts. You don't define every particular detail, but you just create a general concept. Okay, and here is very important to define the objectives of the development. Okay. Okay, what are you going to do with the oil? What are you going to do with the gas? How much more or less are you planning to exploit from the reservoir? Then establish feasible development scenarios. demonstrate, as I said before, or is written before, technical and economical feasibility, okay, in a very general way. And also one screening that is done at that stage is identify potential stoppers, okay, either from the technical side, for example, too deep waters, okay, there are some potential stoppers, too long transportation distance, too far away, the environmental conditions, that you, for example, you have movement of icebergs, so you identify potential stoppers, but at the same time you identify the needs for new technology. Okay, to develop that field, we are going to need, for example, subsea transport over more than 100 kilometers distance. It won't be possible any other way. Okay, so you have to find a way to ensure that the flow will go uninterrupted from the reservoir all the way to shore, for example. Okay, and a cost, again, this is very simplified, but this is not already in terms of volumes, but you're going to put some cost of the facilities. But of course, these are really rough estimates, and they are going to have a very big uncertainty, a very big variation. But a better cost estimation, including the system that I'm going to use. Okay, so that's on the feasibility part. And again, I have another decision gate. By the way, these decision gates, they have a name, in at least in Norwegian. Okay. BOK, I think, is this one. Let's see the document from them. Okay, BOK, DG1, BOV, and BOG. Okay, gjennomføring, konkretisering, and videreføring. Okay, so these are called BOK. So if you just, maybe they have this, they don't use DJ, but they have this nomenclature. Okay, BOB and VOG. Okay. So you reach, after you do that simple analysis, you reach another decision gate, and you reach the next phase, which is concept planning. That this is looking more in detail into all the different concepts. What we say, the layout, they start to look at the layout of the production system that I'm going to need. And you already are going to have a favorite, so you're going to select a viable concept. So this step is important because you analyze, you have a selection of concepts, and you're going to select from one of them that is going to be the most viable based on some indicators. Okay, and document preparing for decision gate 2. Okay, I will prepare all the documentation to justify what are the studies that I have made, and the outcome was this particular concept. Okay, and within this stage, you have defined the commercial aspects. Okay, which are legislation, Okay, what kind of system they have for exploitation of hydrocarbons in that country, what kind of agreements, what is the framework that I'm going to use, what is going to be the share of each partner. Okay, then the licensing to renew, if I'm going to get the renewal of the license, financing, where am I going to get the funds, and we're going to cover that part very briefly in the maybe in a month. Marketing, what is the destination market and supply. Okay, this is especially important if it's a gas development. You will see, or you are going to read, that you need to have a market. Okay, someone that is going to use that gas, and you have to establish a contract to be sure that they are going to buy it from you in a regular basis. Okay, so this part it's involved here to plan the supply. And also taxes, what kind of taxation do you have. Then comes the interesting part for us, which is the reservoir behavior, okay, and the depletion strategy. By the way, by this time, after you prove the business case, you have here to establish a multidisciplinary team in drilling, production, reservoir, geophysics, geologists, that will help you, and offshore engineering, etc., that will help you to do all of these tasks that you have to make in the planning phase. Okay, so you really have to have a team, and then each team is working with a particular element. Okay, for example, this reservoir is working with creating strategy. How am I going to, and this is usually done by creating a reservoir model. Okay, and creating the reservoir model has two parts: the static modeling. Okay, and here we have to input the structure of the reservoir, the size of the reservoir, the bounds of the reservoir, the connectivity of the reservoir, the faults, the properties of the reservoir, the rock properties, the porosity, the permeability, etc., with all the limited data that we have. And then we have the dynamic modeling, that is going to give you how much, if I put this pressure, remember that the reservoir model is just a box, okay, or we can put it like this. Okay, if we say that this is our reservoir, very simplified. Okay, let's say a single well reservoir. Okay, there are different ways, but the static, usually you try to using a commercial tool. You use Petrel, or you use how many of you familiar with Petrel here? 1, 2, okay. And Eclipse, 1, 2, 3, okay. Okay, you make a model, and then with this model you say, okay, how about if I impose here a pressure that I will be operating my field on the well is this value. Okay, how much will I be able to produce with time if I force that pressure in the wellbore. Okay, and with that you can compute the production profiles. And many people use reservoir model, even though there are another reservoir simulator. Or you could use material balance plus an IPR equation. Okay, there are different ways to do this. You can also use decline curve analysis. Okay, well, you have the static, where it's just populating the model, and then dynamic, that is the behavior in time when you apply certain boundary. And this condition we will see that is very important because it dictates how much you can produce at a given time, okay, the pressure. But just keep in mind they have a model and they put a condition in the well, and then they obtain the production profiles, okay, the rates of oil, gas, and water with time. Okay. Then we have something to look at is flow assurance. Okay. And we will discuss about it by the end, as I showed you, by the end of the, maybe it's 4 before the end or something. Okay. And that's if we're going to have a particular problem. For example, if we have long transportation line, then we might have hydrate problems, we might have wax problems, the pipes might plug, okay, we might have intermittent production, we might have so much liquid accumulation, and the liquid is going to block the lines. So here we have to look at those particular issues from a very, so here we have hydrates, wax, scale, we have slugging, etc. Okay. Then drilling, we have to have a team that already knows how the reservoir looks like with the input from these guys from the static modeling, and from the offshore guy that's saying, okay, here I'm planning to put the wells, or here I'm planning to put the rig. How do we reach those accumulations? Okay, drilling and well planning. Then you have the facilities guy that's saying, okay, you are planning to produce these fluids, so you will need this particular equipment. You need this separator of this size. You need to process the gas, for example. You need to process the water. You need to have for water reinjection. Facilities. Then to plan a bit how it's going to be the operation. Startup, how do you plan to start up, if it's gradually or you plan to start everything at the same time? What kind of operations are you going to have regularly, and what is the maintenance plan? So at this stage, this particular step, concept planning, you define or you start looking at the details. Okay, it's not anymore just a general concept that is very, very wide. But you start looking at every important element, and these are just some elements that are looking into. Concept selection. So at the end you want to select, when you reach DG, okay, DG2, you want to select a concept. And you also want to have, of course, cost and manpower estimates. Remember that the main driver of developments is the value. Okay, the value we call the net present value, the economic value of that project. And we have all the time to take that number into account. When we are doing very simple analysis and we are going more detail, we have to try to estimate first the revenue, how much are we going to get, the cash flow from the sales of hydrocarbons, and also the cost. When we have more details and our system is more defined, then it's easier to compute the cost. There is less uncertainty. But if you just say, I need a platform with so many wells, that's very wide. Which kind of platform? How much oil do you plan to process? How much gas do you plan to process? What kind of equipment you should have in your platform? Well, when you start defining each one of these aspects, then you are able to get with more accuracy what is the final cost. Okay, so that we have to do in every step. We have 5 minutes. So then we have pre-engineering. Okay, so DG2, we define a concept. Okay, and then here we mature, define, and document the selected concept. Okay, And here we have a selection of the final technical solution. And you have to define all remaining technical alternatives. Okay. Then you have to execute FEED. What is FEED? Front End Engineering Design. That based on what you have, what you want, the final technical solution, you divide in packages. You will need processing, you will need this platform, you will need these wells, you will need this kind of processing, you will need this pipeline, and then after you divide in packages, then you can start making more details and determining what do you need in each package. Okay, a pipeline, I need a pipeline of this length, I need this kind of insulation, I need this kind of support, I need this kind of vessel. In the facilities, I need this kind of separator for this capacity, I need this processing train, etc. So here you define the technical requirements. And these are typically arranged in packages. Based on the final solution. Okay, and here usually in this part you subcontract another company, okay, like Aker Solutions, and they are preparing, these are the requirements, and something that you're going to go to the contractor and say, please, I need this, this, and this. Make me an offer. Make me a bid on what you can offer on this part with these particular specs. Okay. Plan and prepare the execution phase. Okay, prepare. Here you have in DG3, you have prepare for submission. You have another formal process that you have to submit to the authorities. In this case, to the Petroleum Directorate. You have to submit, prepare submission of the PDO. That's a plan for development and operations. You have to submit a report that makes what are the impact and the potential consequences socially and environmentally of this project. So this is called the consequence and impact report. Okay, and you have to submit a more detailed a report called PIO. That's a long name. Plan for installation. And operation. Plan for installation and operation. And then we have 4 of facilities for transport and utilization of petroleum. Okay, and that's the other contact you usually have with the authorities. When you send, after all the planning process, after you have defined very well, relatively well your system, you have estimated the cost, you know, what is the influence, then you reach decision gate 3. And that really depends a bit on the authorities, on the government, to evaluate your proposal. You're going to summarize just to check that you have done your homework, okay, that you have done all the things that I showed you before. And then they're going to determine if you have to make some revisions. Okay, if you have done your homework, usually nothing happens. But then they might determine, well, you have to do this change, you have to review this, you have to review that. So, but this is the main decision point if you're going to proceed with the project, or you have to make revisions, or you have to make major revisions. So you have to repeat the whole process again. Yes? Okay, I think we reached the end of the lecture. So we have this part. So this was the so this was good because we just finished with mainly the planning process, okay, and then we're going to go to the execution and operations, and that is kind of a different set of activities we have to make there. I want just for next class on the compendium, if you can come a bit prepared, if you can read from page, the first pages are just repetition, you can just read, or read the notes, or read them just to refresh. But I want you to read from page, let's see, that's page 9. Okay. The differences between offshore and onshore. From page 9 all the way to page, okay, this is the difference between oil and gas field. Okay. And yeah, up to that point. So it's from page 9 to page 17. Okay. From the compendium that I'm going to upload very soon. For next class. And we are going to, if most of you read it, we are going to make a class activity. Okay, we're going to put you in groups, and I will give you some questions. For next class, read page 9 to page 16. Or 17, was it? 17. Okay, before we close, any question? No? Comment? Someone wants to sing, or no? Okay, so see you Thursday at 2, okay? Same place.